This is going to be a section where there's some odds and ends and basically developing a table for evaluating trig functions of angles around or from 0 to pi or 0 to 360. And so the first concept I'd like to talk about is in the unit circle, it has a radius of length 1. And when you have radius of length 1, that means that the cosine is equal to your x, because it's not that the cosine of an angle is equal to x over r. Your r is 1. So really it looks like x over r, but your r is 1, so this is equal to x now. So in other words, x's go with t's and y's go with x's go with cosine t's and y's go with sine t's. And that's what you're going to want to remember in this particular section. Also, another part, and it can be written as this as well on the unit circle. The point like xy, now you have a point cosine t, sine t, and you could say theta as well instead of t. If you go around the unit circle once, it's going to be a multiple of 360 or 2 times pi k. And so if you want to undo it to get an angle between 0 and 360, you would either add or subtract 360 off of it to get an angle between 0 and 360. So that's just a point that's going to come up. And when you add and subtract those numbers, you will still get the same answers when you take a trig function of a certain angle. Reference angles. Reference angles are going to be the angle that's between the terminal side and the x-axis. Notice x-axis, that's really important. Now, you could remember all of these things and notice that the theta prime is the same thing as the reference angle. However, I think it's a lot easier in this whole section to just think about it as what is the angle that gets you back to the x-axis. Here it would be the same angle. This one, it would be, if you're given theta, you would say, how much more do I have to add in order to get to pi? Or, according to this, it could be pi minus that angle gives you this. The whole minus the part gives you the other part. And similarly on the other two. And that's why I wrote down here, simply to find a reference angle, think about the angle that will get you back to the horizontal axis. Now, when you want to evaluate what a trig function of an angle is, you want to find the reference angle and use it to determine what the trig function is if the angle is outside of the first quadrant. So that's where this table is going to come in handy, is evaluating these and then using them to evaluate the trig functions of an angle. Now to do so, we're going to use a 45, 45, 90 degree triangle. And we remember it's 1, 1, square root of 2. And then a 30, 60, 90, which is going to be 1, square root of 3. And 2. And this is your 30 degrees here. All right, so also I'm going to remember the 0 and 90 degrees. I'll do that up here. You can choose a point 1, 0 and 0, 1. So when I go for the sine of 0, I'm basically looking for what y is. That's going to be 0. The sine of 90, look for y. That's equal to 1. Now I can come down here. Sine 30 is 1 over 2, 1/2. And sine 45 is 1 over square root of 2. Or if you simplify it, it's square root of 2 over 2. And the sine of 60 is going to be square root of 3 over 2. Doing the same thing for cosine, that is your x on these two. So this is going to be 1 and this is going to be 0. And looking at the 30 degrees, cosine, square root of 3 over 2, square root of 2 over 2, and 1/2. Now, the tangent of 0 is going to be y over x, and therefore it's 0 over 1 or 0. And if you look at y over x at 90 degrees, it's going to be undefined because it's 1 divided by 0 is undefined. Then if you look at the tangent of 30 degrees, it's going to be 1 over the square root of 3. Tangent 45 is 1 over 1. And the tangent of 60 is square root of 3 over 1. I want to look at the patterns in this table now. Notice that this is equal to, on the sine of 0, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and guess what? Square root of 4 over 2 is equal to 1. So your originals, you can easily see, are formed by looking at those increase the radical over 2 on each one. Another pattern. Look at the sine as you go from 0 to 90. The cosine goes in the reverse order. And to get the tangent, all you're doing is dividing the sine by the cosine, which is your y over your x. Y, x, this is your y over x. And you can get those values. So really, you only need to look at that first row and you can get the other two. Now, another concept is where what is the sign of the trig function when it's in any of the 4 quadrants? This is positive if the terminal side is in that quadrant. Negative, positive, negative, negative, and positive, negative. Notice that if you're looking at sine, cosine, tangent, which ones are positive or negative? In this one, they're all positive. Sine is positive because your y is positive, and the other two are negative. So I'm going to put sine here. These indicate which ones are positive. That's what the letters represent. Tangent. Tangent's positive because y over x is positive. Sine and cosine are negative. Cosine. Cosine is positive. Sine and tangent are negative. So if you can remember SATC, you will notice that the sine, all, tangent, and cosine are the positive ones. The other ones are negative. A lot of students can remember that as all students take calculus. All students take calculus. Now, I can also remember it as Santa Claus. So if you want to remember Santa Claus, then you can get your positive negative as well. Doing a couple problems, let's say you have sine of 5 pi over 3. The first thing I want to do is graph it. So 5 pi over 3 is going to be right down here because pi over 3 more gets you to 6 pi over 3, which is 2 pi. My reference angle is going to be pi over 3. Sine of pi over 3 is going to be the same as the sine of 5 pi over 3, except for a positive or negative. Now I know SATC, cosine is positive, sine is negative, so this means that that's got to be a negative. And then when you look at the table, you're going to see that that's equal to square root of 3 over 2. So it's a negative square root of 3 over 2. Cosecant, 210. All right, I'm going to think sine 210 because those are reciprocals. And then I'm going to think about the reference angle. Again, if you were to look at 210, it's past 180. This is going to be 30 degrees. So it's 30 degrees. And therefore, this is only going to be differ by a positive or negative, which means that in this quadrant, again, SATC, this becomes negative. So it's going to be a negative sine of 30, which is a negative 1/2. But you evaluate the sine of 210. So this is, we have to do the reciprocal of it. So it's a negative 1 over 2 or negative 2. Cotangent, negative 315, is the same thing as tangent. And let's see, if I graph that, negative 315 is going to go this way, right up to here with 45 degrees left. Therefore, I want to write down 45 degrees, that's my reference angle, and it's going to be positive because all of them are positive there, and that is equal to 1 by looking at the table. So by using the table and reference angles, you can evaluate any multiple of special angles when you're taking the trig function of them.